Hi, Linda.
Hi.
I think we have everyone here. Bob Berger, our senior, is an engineer. I don't know if you met him last time.
I don't believe so.
Okay. And Troy is our new sales rep.
Yes.
Okay. I made you a presenter, so if you share your screen, I guess you get this training started. I'm recording this meeting right now.
You see the window?
Yes.
Yep.
Okay. Okay. So is there, David?
Yes.
Okay. So okay. So I'm not sure how much you're familiar with variation manager, but it's basically if you have design that can run SPICE with that given statistical model, you can basically do analysis given in variation manager. Carlo variable explorer, high sigma, performance and yield analysis. People that do is like a start of the design, they can do very explorer, so they can see where the design is, and with a small simulation. Instead of running full on Monte Carlo, you can sort of run that with the same accuracy similar to those Monte Carlo with the fast Monte Carlo simulation in the so kind of basic in there. So we go over we have a couple of tutorial example in the available with the tool installation. Not sure you guys have that in the installation path. So if not, I'll send it to you, or when you download the software, then probably it's going to be in there. So anything before we jump it into?
I guess can you send any background on how algorithms work? Is it my assessment is it does a few simulations, varying the parameters.
Yeah.
Then attempts to form either some sort of a statistical model or cluster model of the parameters to the measured output variables, and then pursue with more intelligent parameter variation to cover the information.
Yeah, basically, I mean, the statistical model should be available through the the model from the Foundry. If those parameters is already statistical defined there, how the variation different parameter defined in the length, width, and variation. So basically, to look those with the Gaussian and other type of, and you can over the top you can define that temperature, different corner you want to do that. So it take into that consideration, and an algorithm does that intelligently. Their IP is formed into the matrix, and depending on those calculations, it run those simulation and basically minimizing those. Maybe in the XFAB there's so many corners there. Maybe if using TSMC and other, probably they have more variations there. So those look those one with the and reduce the number of kind of with the same accuracy run the algorithm. That's the basically proprietary stuff in there. But I cannot comment on that. Probably have to if you need more information how that works, I can have to involve one of the developer from France. They a little bit we can arrange the next meeting or so because they are not available today.
If it's critical, I'm extrapolating from what
Yeah.
I know about artificial intelligence to
yeah.
to how
No,
this
I mean
would,
once you have, I mean a matrix with all variation, you have that. So that's the part of that they develop the algorithm
yeah.
to minimize that. I mean, if you look at that, even we'll go like you running, 1,000 simulation Monte Carlo, but in the end, if you see the report, it says effective simulation is like 200 depending upon the parameter. So then instead of running those 1,000 or 10,000, or if you're running more than that, so it's reducing the number of simulation, giving the similar accuracy. So it's like design, basically everything is to the market, right? So
Yes.
so you have spending less time on the simulation, right? So you have can do other things. So and confidence level, you can have that. I mean, you can run basically, in my opinion, I ran that basically from my past experience, design, memory, analog blocks, or running all the Monte Carlo on the bit cell and other things. It's a lot of time, but with the reduce simulation, so I can predict that design is okay with that given temperature change or voltage and other global parameter varying, or also the local with the device. If you have that some big device, they can call that depending upon those ones. So you can alert that. That's the they're called variability explorer. So you can see that design when it's a little bit more stable, then you can twin to the more accuracy and increase the number of more simulation, like a high sigma, how far you can go, 3, 5, 6, whatever your requirement, that you can see that. And those, it can increase the simulation time too, because it need more sampling to that. So again, once the design is stable, then you can run that. Is again, after that is CPU, and with the less numbers you can hold the metrics also.
I have a kind of a general question. So the analog design flow is, you start out from a very Explorer, and then
okay, go.
The fast Monte Carlo. In general, I guess the purpose of is to reduce the final Monte Carlo runs, because one approach is it could use fast Monte Carlo algorithm from the other place, run it on the top, and then we'll get the distribution that way.
Yeah. I mean, that's again, if you running like 10,000 simulation, just looking the Gaussian from all the corners, so that is consuming, right? So with that, you can the algorithm does that. It reduce those kind of things. So if you're running 1,000, it's effective, like time with all the variation, all the parameter, it reduce that your runtime and also the accuracy, right? So I don't know, there's no you still can run that, but again, with the end, you need to see the results, to prop and other things. So you can do manually doing that. So it's done in the tool, so you don't have to do that. So if there is a fail, variation, like the simulation failed, you can, from the tool, you can see there was waveform is and all the measure statement, and you can bring the wave viewer in the design through the variation manager. Using the simulator, we're going to use Smart Spice anyway here, but you have the other folks have their own A-Spice or Spectre. They have the hooks in there. They can bring that and run that and check the accuracy too. If feel like though my simulation shows something, a variation manager, doing that, those can be correlated in that fashion too.
I guess my question is, why do we need a variation explorer?
Variation explorer is just the design is not stable, right? So you don't want to run all those simulation before even going, right? So see that trend, basically how the design is performing on those conditions, right? As design is more stable, then you have to look for the other sigma, 3, 4, 5 sigma more, then you can have that. But you don't spend the time on those things, right? Because the design is still you hashing out those and also see the variation, how much you can have that with those the development stage. Right?
But if a design which I verify through smart spice, is I don't know how you define stable. Functionally it works. Electrically parameter, it meets all the electrical parameter. At that stage, can I just go to the Monte Carlo? Or
yeah, you can. I mean, it's still gonna run those under the hood, run those one. But you can run the first Monte Carlo. You don't have to run the variability explorer, right? So because you are already at the stage. But if you doing high sigma, like design is like if you're running 6 sigma, then the number of simulation gonna be increasing, right? The variability is just to give you the full blown. I can say the things like when the design is passing. For example, you starting the design, device parameter is not stable if you are running like low temperature or high V other stuff like those. So those variation. Then you on the corner, if you look at the Gaussian waveform, on the corner, the lower corner or the upper corner, how much variation you want to see that matching that. Those can be further enhance those capability with the using high sigma and high sigma yield, all those steps. So variability is just give you the overall picture. You can tune in, or my design is not going to be probably not going to be yielding in this corner or some other or the lower or high end of the tail. Then you can explain or make sure design work on those given conditions.
Okay.
Yeah. So as I mentioned that it's run the SPI simulation, right? So it's basically the takeaway from this one is the spending time on the simulation is less, and you can do different checking all those instead of doing those before basically Monte Carlo stuff.
When you set up a simulation, do you need to specify which input parameters to be able to look at the thing? Or so I refer to the webinar where there's an amp and it's focusing on the bandwidth and the gain. Those parameters are
so you need
reported. But if you're also interested in power consumption,
so I mean,
if you specify that.
You need to specify that. Okay. So whatever you want to measure that.
It's going to take whatever you specify
what you specifying
as the
that.
output.
So
that's
called
what it's
test
going
bench.
to optimize the algorithm on.
Yes. Yeah.
Okay.
So like for those are just small number, but you have a different number of measurement you're doing there, looking there. So those can be, that's a function of test benches. Basically, you can define there. Here in this example, I'm just opening this pic. So these are like AC gain, just few of them. So right. So price, these can be otherwise define those one. Right. So any you want to measure that, you can define that or update the temperature, voltage, or other things. Then can show up that you can limited amount of those one, or you can have that number of them. Then it's going to show up here. So let's start with that. So this is the file OPAM, or you can have your own design. So we're going to start with a new project. Then if you don't have anything, so you can say add test bench in there. So this is the net list basically comes with the everything. So this is the net list. You guys can see that. So this is the net list, right? Library models here, and net list of OPAM, and all the spice, basically option files, parameters, and you can do plot, AC, and all the measure statement. So we say OK. Here we're going to pick that. I can go over the setup again. Basically, I'm just going to load this one while we talk. Okay. These are the parameters we define in this netlist, right? This one, and you can here DC gain, cutoff frequency, UF, and phase noise. Okay. More parameter is going to show up here. Then you can run those simulations. So these are button different. You can the two corner extractions, including you can define your own parameter. It will run that and give you the net list. With the Monte Carlo, you can run those other simulation. You can follow those ones. So the second, you can fast Monte Carlo. Equivalent sample is 1,000. So run all of this, or you can define you want to run those ones. So basically, kind of interface is defined. So this is just I loaded that. If you have other question on this one, we can go over. But the option phase defined here. This is the main minimum. Don't have too much change, but you can change those where the directive is, how much size you want for the allocation with the saving result. If you don't have that, the software will basically keep few, then other one get deleted. Right. So Monte Carlo, fast Monte Carlo precision is 5% defined here. So if you don't, say okay, you want to change that, you can do that here in the options. Okay. Internal tools. This is we use Smart Spice simulator. This is as executable, and this is the option we're using. In the background, this in file node mode. Spice viewer is just smart view on the. If you have a spice or other, you can modify those things accordingly and TR0 forward. Right? Basically other simulator supported too in that. The setup is minimum basically, and once you have those net lists, like you have the band gap, it's good to go. And if there is any error warning, you can check the file that is going to be in your home directory. Is going to be .silvaco directory. Under there's going to be variation manager, and there's a log file. So you can parse those. See error. If you're not running, then you can say the detailed error of those. Need to fix those. Okay. So you can save those options and close. If you don't do it, won't anything do that. So, but I'm gonna do it. I'm gonna open the project that the setting. So basically, now you see the values there, right? So the one of them is this. This is your lower spec and upper spec for those one for those parameters that you want to check those one, right? So that, again, you can do both tail, left or right tail on those. If you look the Gaussian, like left and right, so you can define those. If you don't, you can both of those ones. So these are necessary to when you're looking those. Like say again, you have to define there or any value. Then we'll work around these parameters, check those when how the accuracy and also they're gonna fail or something like. Okay.
So, yeah.
Yep.
We are talking. So for effects LSL and USL, also the both tails.
Do both define. You can do that.
If, for example, if you do fast Monte Carlo, you don't need them. If you know, then you indicate them, and the tool will check if there's any fall outside the limits. But it depends. It depends on analyzers. In some situations, you don't need them. Okay.
Okay. This a JB or?
Talking, yes, JB.
Okay.
I don't see him joining yet.
Oh, okay. Yeah, he said he got onto that. I didn't know. So okay, perhaps you can jump it in. So anything like if I.
Thank you. No, it's I mean, this is inputs, but it's mandatory for all analyzers. For fast Monte Carlo, you may put them or not. It depends on what you want to do.
Okay.
So if you don't enter in any limits for one of your measurement parameters, it's not going to affect the effect on how the simulation proceeds.
Not have on any effect, because when you are Monte Carlo, the Monte Carlo, it will give you the distribution. It could be or not, but anyway, you will see the distribution with the mean max that gives your Monte Carlo.
Right.
But if you fix LSL or USL or both, the two give you the samples that are inside and outside. It will indicate that, okay, I simulated maybe 9 samples which are outside your limits.
Right.
Okay. For example, you can compute a yield like this, for example.
Does it compute CPK or CP type statistics, maybe?
In fact, it's CPK. It's not indicated. I'm not sure, but in this analysis, it's it's old. Okay, I'm not sure about that.
Okay.
You will see. I mean, I believe the gender can run it, and you will see all the information given by the fast Monte Carlo. The gender you on your fast Monte Carlo, no?
Yeah, I mean, I can run that quick. We can run that, just sample. So what's running? So it's gonna say and fast Monte Carlo. As Firas mentioned, you can start with that because you don't have that design looking those. I think that's what it comes under the variability analysis. You can see that, then you can turn in those parameters you're going to specific to the design. So we'll say at how much a simulation running that or you can open the console. Here you can see basically quick any warning error, not going to be details. So it's progress here. You can look at, and also other way you can say that this is simulation console. If you click on one of them, it will show that it's done how much loading those all the library and other things, and see how everything is there, then generating the all the param basically measure statement and different PVT and other conditions. So it's done here. So it's as it keep going there. So see how fast depending on the machine and how many LSF you pass there. So it's pretty quick on this probably design. So as you number of devices, and probably going to be a little bit more time to take those one. Right. So you open that file. After that, check that in the directory. It's going to be in that simulation directory where you're going to be running simulation directory here. So all results are going to be with that. Pick any number there. So if you have a log file there, M0 and all the AC analysis log file there too, you can look those conditions. Measure statement here, same way and that's kind of information get back to going to the plot after when all the simulation going to be done. On the face.
So maybe we need to mention that the fast Monte Carlo is incremental.
Yeah.
It means you can start with by doing the equivalence of 1,000. If you have time or resources, you can go for 5,000. The tool will start from the first analyzers, not from scratch. So they use the first simulations. We can show you that. I mean, if for example the fast Monte Carlo terminates this one with 400 then you go for 5,000, and Toad will use the first 400. Maybe we'll be adding new simulations, 30 or 40. And so it's incremental, and you will have more speed up if you go for more Monte Carlo. So the more Monte Carlo requested, the more speed up the tool will give you. For sure, yeah, more Monte Carlo, the most accurate, you know.
Okay. Hello? So yeah, so I mean, when done, you can add any other, add analysis. These type of analysis available here. Okay. So when it's done, you're gonna get the report like this one, right? So it will say that you can just I ran only two. They're they're active. These are not active in this. So total number of simulations used here, unused nothing. So you say out yield this much, is this, and if out of spec these, there if you click that, it'll show that which simulation is that. Then you can browse that one or output or anything like from you can view that basically what's happening here. So this is basically summary. As you have the spice run, you can look for the wave or any other thing like that from there, and see what causing those ones.
How do you read those? Can you go back to the device?
Yeah.
View?
Okay. Yeah.
So you list like a P almost 45. I'm assuming.
Yeah.
So okay, what numbers?
Yeah, PMOS is your P45 from the device, right? So this is the PMOS here. Right. This is the right.
Mm-hmm.
Same with the MOS there. So these so these are your instance name and the device. You're gonna see that that's the number is coming from.
Is it only is doing the Monte Carlo, and all the Monte Carlo samples are fixed by the manager. So use here for each run, for each sample, they will set new values. So if that with your classical Monte Carlo, this will be the same process. If you do 1,000 Monte Carlo, it's stochastic values for each run. So here, Fast Monte Carlo has full control on the tool and set itself each new values set for each run. So this is what you see here. So for process and all the parameters.
But which device is causing out of bound parameter?
It's you here in this table. I can see the parameters and the values now. You have inputs and outputs.
Okay. Output.
So coming from the SPICE simulator.
Yeah.
And inputs, it's the values given by the Monte Carlo variation manager Monte Carlo. Okay. It's the way to do Monte Carlo, but the only difference is the Monte Carlo is doing many less runs. For example, instead of 1,000, it does 312, I guess, here in this case.
Yeah,
312. Okay.
I guess what my question is, you see that there's, the DC cam has a 14 out of spec, so you're trying to tweak it.
The out of spec is only TCAD and indicated on LSL. So you can see here the red part indicate you that we have simulations outside your specifications. It's all. If you remove this LSL, you'll not get any out of spec. So it's up to you if you want to, if you have specifications or not. If you want to use fast Monte Carlo as a classical Monte Carlo to compute your yield and to see if you have something outside of spec and then do them. But it's not really the best way to do it with the Monte Carlo because to compute a yield, accurate yield, you will need a huge number of Monte Carlo. So for this, we propose in VarManager other analyzers like Variability Explorer or the high sigma analyzer.
Answer your question, David? All right.
Well,
I'm not sure you understood.
Yeah, my question was that your distribution, whether it's out of spec or not out of spec, let's say this distribution is not 6 sigma, it's 3.
It's only, sigma defined is minimum here.
Okay, so it's 1.2, right?
Yeah, 1.4 there.
You want to make it 3.
Yeah, so if you then you can, so if you have like a high sigma or you can run other simulation, then you can define here, like I can do 3 sigma basically or 4 sigma, right? So if you do that one, and as I mentioned that it's gonna increasing your, what happened? Okay. Right. So see how that sample number increases here. Right. You see? Okay.
So, if you excuse me, if you just practice the fast Monte Carlo, maybe need really to assist again the methodology. Okay. Fast Monte Carlo is you need to see it as Monte Carlo. So if you want to study 3 sigma, if you remember our presentation, it's you need let's say 100,000 of Monte Carlo runs. So you want to study your design to 3 sigma accuracy. Here, what you get in this report only what is your output statistical distribution based on your Monte Carlo analysis. So he will indicate you the mean, max, mean, and sigma. This really corresponds to your statistical distribution of each measurement of your design. For gain, for out frequency, you have mean, max, mean, and sigma. And so the out of spec, because we indicated the LSL, so just forget it. You see the shape of your distribution, you see if it's efficient or not, you see which is the sigma and the mean max. Okay, this is only, you need to see it as Monte Carlo. It's really completely similar, but the same difference, we need many less simulations. Now, if you want to study your design to 3 sigma accuracy, so then you do 1000 Monte Carlo with the fast Monte Carlo and use the Variability Explorer that just Gender mentioned 2 minutes ago. We don't really advise to use the Monte Carlo for 3 sigma or more because 100 simulation is really a huge number. And we propose which is the Variability Explorer. So Variability Explorer images a fast Monte Carlo with a main difference that it will focus on the tails of your distribution and then to detect the fails, if any. So we do this analysis in some ways, but the idea is really, instead of doing the Monte Carlo everywhere, For example, if you do it in the middle of the distribution, these samples could be not really very useful. So we explore with if for controlled budget. For example, you can say my budget is only 1,000 simulations, and I want to study the line to 3 sigma. So the Variety Explorer is more suitable for line of analyzer. But then you need to see it as multicolor. That's it.
Is there a way to take this data and look sensitivity analysis standpoint where this has the most effect on, say, DC gain or this component within design?
You're asking, I'm not sure to catch it, but you're asking if this analysis gives you the more sensitive parameters for devices?
Yeah.
So this one is only Monte Carlo. Mm. So it gives you this all statistical information based on the Monte Carlo done. But if you go to, we have analysis that will help you getting the sensitive parameters of the devices. So you have what we call the local variability analysis. This is good for analog people like you. This one will give you the list of the most sensitive devices with limited budget. So for you can decide that the budget is 300 or 400, example. The other one is the Variety Explorer. Variety Explorer is more general because it will explore the tails for you. So it will detect if there is any fails, and so it will indicate you the most sensitive parameters. This one gives you the most sensitive parameters, and detecting fails. The variability will give you the most sensitive devices. Okay, so with 2 because I'm sure that you know that the sensitive parameters is one of the most challenging problem, and it depends on the technique that you use. You may find the parameters, or you may lose some of them. We have different methodologies, different techniques to detect that. So you here Variety Explorer and local variability. Okay.
So local variation explorer, is that basically studying the matching characteristics on a,
the variability. Local variability is, you need to see it as an advanced sensitivity analysis. Well, it's really very useful when you have big designs. You have many devices. If you want to do that with classical tools, you need a huge number of simulations. Variability is based on really an innovative technique. So you can use it for big designs, but it's very limited budget.
Okay. I think it's really a terminology issue. Like the question, what do you think? A lot of designs are based on ratios of resistors or transistors, and so the design is studying the changing, referred to as the local variation. But that's what you're seeing, both local and global variation, I think.
We can. I'm really the final expert of all these details, but then with this tool, Variation Manager, you can decide to study global, local, or only local. Okay, you can do that.
Okay.
I mean, kick it off this one. See, should be factors, and we can see those both results. So I mean, that's why variable visibility gives you a little bit more at the front, then you can see the endotail here, as Faraz explained that. So you're looking basically this failing end, but given that 58 of C gain, so these parameters is checking that with that. So that's kind of a. So these, I mean, again, high sigma. Again, how much budget you want? If you want to see the bigger number, then then those the simulation gonna be budget gonna be all bigger and goes for that. When it's finished, then it's the graph gonna be, we can look at the device which are sensitive to the local, so that's probably have a little bit more picture clear from the.
You comment with parameter or device is sensitive to local local version or.
I mean, Flash can correct me.
Local variation. Yes, it's local variations, right?
No variation is in the matching.
Yes.
Okay, so terminology of local variation is what different people use different type of terminology. They use they use mismatching for
yes, it's to be distinguished from global and local and global variations.
Okay, so your global is the process variation. Yeah. Your local is mismatch.
Device. Yeah.
Okay.
People process, it's a on you have both. I mean, depending, but it's coming from the process, but it's global and local. So this matching local, yes, right.
So the Explorer would show you the local variation only, and I mean, to show you the global variation as well. Or
in fact, I believe he ran about the budget, but he ran local variability. Local variability is really to you can include the global also inside, just to detect the impact. But the idea is to find the sensitive devices to variations, right? But you can also the global variations. So in some situations, just to show you what is the impact of global on the local or not. But if you special, let's say case, we can clear the team to give you more details, which is the most consistent. But the sensitivity analysis, as I told you.
Yeah. So in our product, we have many different electrical parameters. Some parameters are sensitive to global variation, and some parameters are sensitive to local mismatching. So when you are in US, when you define those measurements, and when you how to manage this parameter is sensitive to global, the next parameter is sensitive to local. And
okay. So I guess it's global. It's the platform, and it is statistical parameter, so it's considered as global parameter. So I mean, it's a classical format for all the spice. We are not modifying that. We are not modifying anything, isn't it? the code will understand if this one is global or it's local. So that's it.
So if I want to study local, I could turn off global, right?
You can. Yes. Yes.
Okay.
Yes.
Vice versa.
Yeah.
Right.
But the global gonna affect your local too, right? So you cannot. I mean, you can do that, but still be impact of the global on the device too. The device sizes and other, they're all gonna be variation of VT and other things.
Yeah.
So I mean, you cannot. I mean, completely isolated that, right? So it's still gonna be fact, but you can intelligently define that a little bit more.
Yeah, some degree, but to our terminology, when we say local, we in the matching of the two transistors.
Yeah, I mean you can. Yeah. I mean it's mismatched when you look in the op-amp or SAM, so it's like.
So the global variation has a very little impact on the mismatching because they all vary at the same degree.
Yeah.
Sure.
So then when you're gonna see that those factors, this device and this one, then you're gonna see that they are affected by those in this analysis probably when you're doing the local visit.
But that you did not modify the budget, so I think the budget is too high. It's was indicated by default for other.
I know I did like 1,000, so I think it should be done.
So it takes too much time for this kind of design. So if the budget, you can do it in general with limited budget. So, but as I told you, it's dedicated really to big design. If it's a very small design, the benefit of this kind of analysis is not really clear because, I mean, if 5 devices you not use, you will not use, I mean, more than one simulation to detect. Okay. So this is only an example, but variability. But Variability Explorer, I believe it's is the most important and interesting after the Fast Monte Carlo, because the Variability Explorer, you indicate the budget, and then it will detect the phase for you, if any. If you don't indicate LSL, USL, it will find the most extreme samples. So very interesting. For example, you can indicate I want to study my design for 3 sigma. 3 sigma, I want to find me the most extreme runs. For example, 10 extremes. So they will give you on the left of your distribution only the 10 extremes, and you have access to the net list and can study if everything is correct with this, and it will also give you more information about the sensitive parameters of your design. So it's the same analysis will be done. So local variability, you need to stop it. It's you did not just
quit.
Okay. No.
Okay.
You don't exit. You click on the right on the right button. No.
Which one?
Below on this one, click right button, and then you can do stop simulation or stop analysis. So yes, exactly.
Okay.
So you can you can stop it. You can start again.
Okay.
Okay. It's about too high for this. It take us too much time. Okay.
Yeah. Okay. I think I so you can
but you should go to Variety Explorer if we don't have a lot of more time.
Okay.
Right. There is another one running. I'm not sure why. There's another process running level variability here. So please stop it also. Yes, please stop this one also. Cancel. Yes.
It's still running somewhat.
No, because it will complete if it will complete the simulation.
Oh,
you know.
Okay.
It will not get. It will complete and stop in general. Okay, it's okay. So go to Variety Explorer, please.
Okay.
So I like to explain this one.
So should we leave that sample 1,000?
So the budget. So the first input is that the number of extremes you want really the designer wants to see. It could be 10 side, left or right. It could be 5 or it could be more. So here by default is 10. Then you have the Monte Carlo sample size. That will be computed automatically to give an idea. You want to do this with Monte Carlo, how much it will need you. You have the sigma. Now, if you change the sigma number, for example, if you put 3 sigma, please, which is okay. So you can see that the MC sample size has changed automatically.
Yeah.
So if you want to detect 10 extremes for 3 sigma, you need 7,400. Now you have the fourth, which is the budget.
Yeah.
So the budget here, it depends on the designer. You can start with 500. What was 400?
Okay.
So Variety Explorer will tell you if the accuracy is really enough. It will give the information and it will indicate you if there's the accurate enough. So you go also by incremental. So you can do with 300. Then you can say, okay, let me do it with 400. So the tool will use the first 300 and add to 100 only. So we can start with this. Now we can change the number of extremes.
Yeah. Gain the sigma number.
Yes. You can change the 3 sigma, for example. You can put it for 3 sigma now. So it's going to indicate you to yes. You can see that the law of Monte Carlo has also changed in this case. And now for this with the standard budget. Okay. So it's really controlled by the designer. It depends on how much simulation he accepts to run, depending on the resources, simulation time, all this. Local variability is still what we had been done, the local variability.
So PJ, the ideal budget is the same numbers, the sample size, right? Since you don't have enough tools, so you reduce the sample size.
Yeah. Exactly. So Variety Explorer is here to help you getting information, but many less simulations. This is the idea. I go with Monte Carlo, classical Monte Carlo, or you use variation manager analysis. As Monte Carlo was accelerated, Variety Explorer you compute what's the budget available, and Variety Explorer will give you the information and will indicate you the accuracy, and if it needs more simulation to be more accurate, or if it's good enough. So automation you will have them, but for sure, even with this small budget, it's all to go really more far from the classical Monte Carlo. I mean, you do 300 Monte Carlo, and for sure your distribution will not be enough. and 300, it will give you a kind of accuracy into 3,000 or more. Okay. Once again, between Variety Explorer and from SAS Monte Carlo, the SAS Monte Carlo will build the whole distribution for you, so you can see it everywhere. It's similar to Monte Carlo, but Variety Explorer will explore more, focusing on details. It's taking care of the distribution, because not here where you have the critical information. Let's say the Variety will go focusing on the tails, doing more simulations on the tails, and if detects some fails, it will indicate all these extremes of distribution.
So then we have to change the heel left or right.
You can. It depends on the designer. You can explore tails, or you can only in some situations you know that it is your interest is on the left or on the right, so you can explore. So it's better for the Variety Explorer if you decide, if you, for example, on the left, so the bot will be more used for left, not for the right. If you indicate left and right, so you can imagine Variety Explorer will need to use this budget to explore both tails.
I think this won't even.
Obviously, a problem with the local version that's running. Yeah. For the budget, let's put 300 please only, even if the accuracy is not enough, but let's just to show what kind of results we can get. Okay. Also, if you start with Fast Monte Carlo, as we did, and the tool runs a 300 simulation, for example, if you save your project, you start another analysis. The Variety Explorer in this case will try to use the first simulation done. In some situations, maybe in this one it would use 200 from the older run and add a new 100 to complete its budget. So analyzers use the same database of simulations, and the analyzers are incremental. So when you start or restart again, you don't lose what you have done in the past.
To save the database, right?
Database, just to say that the simulation done already, it's shared in the same data. So.
Okay. David, while it's running, I'm looking and see this var file. Then gonna see the message, as running now. The log file gonna see that if it's done correctly or end simulation, right? So he's gonna see any error or message warning, so you can, check that what's going on. If it's not finding files and other things, this is a good information for that too. Right? So find these for the project, like these are parameters. Then if you have more, they can show up here. Only one license. When this is done, it's a success here, right? So those data creating the. So this is log file with the other tools, but it's in the different location, basically in the.
Okay.
Yeah. So I mentioned to you, I ran your gap. I mean, I mentioned to you, but you can, your example or there are a few other examples in the tutorial. So they all have netlist. You can in the batch mode too. Don't have to be once you have. So we have bit cell, model, SAM, and other stuff. Those are like a different type of analysis and a different value statement, and how those are. Basically, the concept is same. I mean, in the past I did that. I mean, if the models are not defined, like they don't have a statistical model, probably you have to mess up with the model. You can define your own kind of, then you have to define the same as from the syntax. If you look at a SPICE, Monte Carlo and variation, you can define those on that parameter, Gaussian or blah blah, with the percentage, then add into basically that will do the job too. If using some proprietary, or they don't have that statistical model, but I'm not recommending, because that's going to be a little bit more work to doing those ones. So okay, here it came. Okay, this is the variability explorer.
This is the Explorer results. So as I told you, is this the QQ plot results? It's not the classical distribution that you can see with Fast Monte Carlo. The blue points are the most extreme that we ask the Variety Explorer to give us. So you have at each tail 5 points in blue, and you have access to this netlist, so you can study them. So I have the same kind of results for each measurement. And on the left and the right, you have these tables indicating the mean and the max that each variety is able to give you. So this is 300, indicating that it gives 3,074 Monte Carlo runs, but it's done with the 300. So this thing here is that to give you these extra values, and with your plot you can see if it is or not. So we can see with the first one that is not a Gaussian. I believe that with the Fast Monte Carlo, this is what we could observe with the Fast Monte Carlo distribution. Although it indicates it on the left LSL at 3 sigma, which is value, cell at 3 sigma. So this is also to give you the max, but also the limit for 3 sigma accuracy. So we really advise analog designers to start with Variety Explorer to have information about their designs and to study the extremes with a small budget, with a fully controlled budget. And once you are confident with your design, you can Fast Monte Carlo, for example, equivalent to 50,000 or to 30,000, just to make sure that everything is good and you have a good look at the distribution completely. So this is what you explore. So different. The philosophy is different from the Fast Monte Carlo.
Trying to interpret the the probability plot here. It's you see in over the. I'm looking at the bottom one. So in over 2 sigma, plus or minus 2 sigma. Then we have the outliers, and there are few outliers in 2 to 3 sigma range. So because of the algorithms method of exploring outliers, or is that an actual characteristic of the design we're looking at?
the Variety Explorer, as I told you, is not, it does really focusing on all the distribution.
Right.
It starts with some samples in the middle and go for the tails. So all these points, green and blue, are simulated. These are simulated, but Variety Explorer will not do all the Monte Carlo. So
that's how it's optimizing the number of runs. It figured
Yeah.
out where the
Exactly.
plus or minus 3 sigma distribution is, and it's smart enough to go jump to the tails.
Exactly.
Okay.
Exactly. Okay. Exactly.
So those tails, could do sensitivity studies?
So if you go below each corner here, it's normally. Oh, this is a first table, please. This is a small table. We indicate the corners, and so it indicates the parameter depending and getting some kind of distance of the middle. I'm really not really to explain that, but this indicate you for the corner and the measurements and all the distance for that. So use this kind of sense of the corners given and give you a list of the parameters. So if you now use this table, you have the device, the parameter, and the normalized distance nominal. So you have a table of all the sensitivity of all parameters depend on for each output. So
these are, David, your local parameter device W and L. They are like depending on oval that comes VT and other deposition. And depth.
But the Variety Explorer, I'm sure that we can complete this information for you. But Variety Explorer has all information about the sensitivity of the parameters. And if there's too many parameters, it will do a kind of cutoff and dedicate the most sensitive. But it as a normalized distance nominal, which you can imagine it's the sensitivity. Okay.
Full model, say for the transistor, there, like it's just variation. It's adjusting the length and width. But if a model has other parameters that it's, if this model has Monte Carlo local amp parameters, other local parameters, they would show up in that list, right? In other words, the length and width are the only things that are in the model.
Probably this is it's a model, just simple. Okay. Yeah, so these if you look at that, that's why I say you have XJ and mobility and VT. So these kind of comes in in the global. So these are, so if you have that, I think it shows up here too. Maybe other example.
If it was just, if other parameters are not causing the sensitivity, it just does not display them.
Yeah. Core thing, we have only 2 of those. Then if you have a number of more parameter, it's gonna going with that. If you have like a 2, then if you further 3, 4, then it's gonna check with the corresponding different. So the simulation too, if you click here and simulation, then it will again same because you already ran the spice, or so you can look the what's going on. Input is same way here, output, and you can, if it's not there, will generate that. If not, then you can say okay, see, it says it needed to generate that, because that's then it will run the spice again and generate the waveform basically. Right. Not if you say not on the disk, that means it keeps some of the not, because I need so then it will say that it's not in the disk, then it will generate that, then you say okay, we was see it's running that, now it came back, and then you can check the form if it's ran again, and then you can check those simulation again. Point, as mentioned, is corresponding to the simulation, so it's not like if it's not there somehow removed from the disk, then you can say generate that. You can look the waveform, what's going on, and that's what I mentioned before. It's a good start. Then you can see okay where they are. Then you can target those as you want. The middle one is okay. So those things. So then tune in to your other runs basically, and you can port again. You can save that HTML or other format. Then you can save those things in there. While it's running, you cannot modify test bench. Then after that you can add other if you want to these up there, you can say add to the test the other ones, you can add test bench there. So the parameter these is coming there, and you see that I can change temperature here, right? So if you can change this one and run that again, basically modify that, and as mentioned, it has the data there increment, then will increment accordingly. So you can say, I need to run that 27 here. I can change temperature different, then update. After that, update test bench. Then it will to go again. So if you add other ones again, you can add that similar way. It's just again test bench. If not defining, then you can add one stop. Then let's add that. It will take care of those things.
So curious, if you were to go to the help menu, how descriptive are the?
One is not much actually. It's it's just say. The manual is actually not come along there like Spice. When you help, then you can click on the PDF file will come, but not in this one. So the PDF is just.
So you have to go to the single manual to find anything.
Yeah. Yeah. So I mean, the manual is not this like then it's basically small.
It should be in the it should be the official release.
Yeah, it comes with the installation where it's with the examples, like see these and also tutorial has or like 3-4 all classes basically has tutorial with the different it's easy to follow that and also the manual is just 100 pages manual. So once you pass those warning and error, after that it's just understanding, right? So how you the graph, what you're going to make it up or things. I think you should have that, but in your SPI, say in the where installation is Silvaco other tools, they have the variation manager there. And in that, under that directory, you should have that. Let me see if I can find If not, I can send it to you. Or
examples you have? Do you have any that are transient analysis based?
Yeah, I think that one. Let me see. Make that thing a bit. This one. Is it DC? Okay.
The noise.
Yeah, for bits of noise.
Okay.
Yeah, that's transient there. DC transient. I think that's good. Okay. So these are some more tomatoes. If you look at the, then you can run in the batch mode, basically defining, right? But the syntax is a little bit different. It's not, but it's like a Java interface. But see, this is HSS, high sigma simulations, and those kind of, they are defined in the manual. What's the meaning? So you can check that yield percent 10. Like if I click here, where it goes, yield 10%, 10. So here is defined as 20%. Simulate budget you can do online to, depends GUI, driven or batch mode. So there's both available to do that. All right, what else we need with the time we have?
So I think that mainly you should start with the fast model of IFT Explorer or Utility. TrueCorner also we have not had the time to mention, but is it will also indicate you it is the global variability mainly. TrueCorner is to be compared to PVT course. PVT is the global, but you can do true corners, so it's similar to BVT, but are statistical corners. So instead doing fast Monte Carlo to 10,000 or 50,000 or 3 sigma, okay, which more than 100,000, it will detect the mean max of each of your instrument. So you can include the VT, so PVT. It will be only the min max. So we are considered at the corners, the real corners of your design. So you can see that also by doing few hundreds of simulation, it will give you the corners equivalent of 1,000 simulation. But only for global. So it's really a true VT corners extraction, what we can call it like this. And indicate for which sigma you want to extract your corners. So you can just sit at the Monte Carlo. You do 100,000 Monte Carlo, and you extract the min max. Where you only with a few hundreds you can do it. So you can. You include the VT, and the tool will generate the netlist. So for corners, the netlist that you can run, or run around Monte Carlo data. So customers that extracting the true corners, and once they have these corners, they run local Monte Carlo around to check.
That'll get for a fixed V and T, but the output are if you vary the parameters plus and minus 3 sigma.
Yes. Yes, you ask for 3 sigma.
Yep.
You ask for 4 sigma also. And I mean, you'll see that really this with a few of Monte Carlos,
yep,
it could be done.
Going to give you if you're looking at one measurement characteristic, it'll just give you 2 results back, right? The min and the max.
For each measurement.
Okay.
Yeah.
These type of analysis kind of, these are just preliminary, like you starting that, then after that going further, like you need more and other stuff. Yep. So these. So
the high sigma is mainly for memory people. In fact, it is, you want to explore to 6 sigma, for example, just for people who are doing bit cells, sense amplifiers. Really, it's more dedicated for memory people. So.
Does this have any feature or mode that actually uses the corner case models? Thinking of means to compare. In other words, we've been doing all of our design using corners models, right? We've done very little Monte Carlo design at this point. And I'm envisioning as we might do Monte Carlo models, way to assess our design, criteria we had used before. In other words, over design.
So Thomas, you mean you are talking about the predefined corners, right?
Can you repeat that, please?
You mean that you are talking about the PDC, the predefined corners, right?
Yes. Yep.
Yes. So in fact, in Innovation Manager, we developed a new tool called Smart PPT. Smart PPT is really a huge number of defined corners. So we can tell you if these corners are all needed or not to simulate each time. For example, if you have 2,000 corners and you want to check each time, it could be long. So the tool will tell you you need only 100 or 150 because this 150 will cover the space of the 2,000 corners. So it exists, but in development right now, we already have tools providing us some cases. It's not in production mode. I hope that it will be in the mid of the year. Need more input for customers. So, any interest on side to because for some technologies you continue to work with predefined corners, but we find that predefined corners could be really also a huge number. So if you are interested, we can collaborate. Just you provide us some test cases or one test cases to understand or link, and then how you do that, and then we integrate this in our tool. So we use Smart PPT.
Okay.
And the development not in there, this one.
Yeah.
So,
yeah.
So,
of course, we're
production.
we're nowhere close yet to being able to take advantage of that. So
Yeah.
it'll probably be before we.
Yeah, no. I mean, if you have it, those you can run those one basically while they can look at any other things you need to take care of. It's a good example too. Otherwise, you have to run best, worst case, or typical.
Okay.
Okay, button I think is simple, not much, tool. Is just a clear simulation database is again. You can clear that. So view is again. So if you open this one, does give you the point. So all the analysis is going to be here. They can plot other things with the field option and other plot going to showing up here basically, and you can figure out which one the sailing point is. With access number of auto specs, so you can click again on the graph. Same. Each point is on the graph going to be like to simulate. You can define X what you want to, basically, parameter you want to look that curve with those points going to be here, similar to that one. And this again just exploring more options with the database. So here you have like color that, so if different type of analysis is going up here, variability, West Monte Carlo or local variability. You can one for all the simulation, then you can do that. So just again exploring the graph.
You've covered the questions we had generated from looking at the webinar demo, and you've given at least me a good understanding of what the main features are, and in particular where we use them in the design methodology. We've talked amongst ourselves. We've recorded this because we have one other team member he's actually out on medical right now.
Okay.
He was actually a Spice developer for many years.
So he's modeling, developing the model. Or Okay. Yeah, no, you can check that. That'd be good. Okay. So, I mean, I don't know. You see this, this manual. So this manual explained. I mean, just loaded that. So this just for whole basically 100 pages, 100 some pages. So it will.
Okay.
And all the chapter by chapter what's there. It's much simple. Everything batch mode commands, and give you like not. Then you can similar example. I mean, you can what it does and how to do that, and explaining the and different options you have that. So this is just much there, but a few commands. But if you run as a Spice, need to be
up to date. Does it cover?
Yeah, mostly. Yeah, it's the current probably. Yeah. I need to look at the installation. Then probably they added whatever that, and you can have that. So this current version actually, this one 1.4 running. So I mean, I don't know, David, or you can take a look in your installation tree with the Silvaco. If you're not, then when they can either myself or somebody will send you the download. Then you can download it, the license, and give it basically with your design, or you can go through a few examples.
So how we get the evaluation?
I think you already guys have the Smart license, right? If I understand.
Yeah.
Yes.
Yes. So basically, I can check with it, Troy, or use the license file, right? So you can he can request that.
Can you hear me? Okay. I'm sorry for interrupting, but that was my cue to come in. Good morning, guys. We decide to evaluate variation manager. I'll just have to submit some an internal document, saying why are we evaluating variation manager. I'll turn some license over to you, so it'll probably take within a day you'll have some licenses. So, when you decide to do your evaluation, I'll need note the following information: your the type of operating system you're using, and your machine ID, and just about 3 or 4 of the technical things that you're looking to evaluate variation manager. I turn around internally, and David, I'll issue you licenses. You tell me any licenses you need. For us, and Jean Baptiste is on here as well. Based on what you've heard, you guys are really looking at just the variation manager program.
So, I'm sorry, I can you now, if you don't have any more questions, we are very light in France now, so thanks for your attention. Thank you. Thank you.
Well, what I would need to start an evaluation, David, it would not take me more than a day once you give the go sign, Thomas and Dave.
Is the variation manager running only on the Red Hat or Windows?
Not on the window, I don't think so.
Yeah.
So mostly, yeah.
Sorry to interrupt you, Tajela. Yes, for now, we don't have the Windows version available. We can generate it, but not in a few days. It will require more because we have to qualify right now for the new Windows 10 and so on. So for now, Windows is not available.
When you mention basic version, does that include Variant Explorer and local analysis and fast Monte Carlo? Or?
Generally, for the evaluation, we provide all features to let you capabilities to and see difference and how to reuse the session database so you can start Viability Explorer analysis and then go back to fast Monte Carlo so you can see the benefits of use and so on. So there is maybe is more too accurate to explain, but there is one is dedicated to analog, so including fast Monte Carlo, true corner, local variability, and Viability Explorers, another package for memory design and solar cells. So I can understand you are more concerned with analog package. We include the 4 features you can try.
Okay.
David, I think that's what the checklist was. So remember that. Yeah, so I'm gonna forward that to Faraz and JB. They can have the what's going on. So those basically you mentioned that all those things. So you can try that basically.
Okay. I guess we will talk among ourselves, and then Troy, we will send you the answers you need to get an evaluation license.
Okay.
Yeah, and how many you need that? I mean, machine D, and he has the whole sheet to fill that up. So we'll, I'll approval from the. My manager or his manager team probably. So I can expedite, once those information, then you can download from the Silvaco as you doing other licenses, or we can send it to the. But we have to make sure that you have the current software like this one.
So David, any idea if you were to start evaluation, would it be week or week after that? Or
I think a couple internal things we have to resolve first. One of them is, for internal eval, I think to make sure we're comfortable with our Monte Carlo models. XFAB doesn't provide local variation models, so we have to construct them from public data. And I think it would make sense for us to get progress on that before we start any evaluation. We need to know that we're going to have good Monte Carlo models before we can use the Monte Carlo tool. We have some internal discussions. The other thing is one of the key players has been working with SmartSpice, so we need to bring him up.
Up to that.
That's the injured engineer.
Yeah.
Okay.
We've come up with a path where we, a subset of, a specific person evaluates it sooner, but that person's pretty loaded up right now, I think. So.
On that, not just make sure you have a kind of, to me, resources for people, otherwise the license is going to expire. It's not a big deal, but still, right? I didn't even do anything.
I don't want to start something that we can't make meaningful progress on. But, fundamentally, it's a goal of ours to be able to, Monte Carlo-based design.
Yeah. No, doing XFAB anyway. I don't know. So model, you questioning their model, or you have other parameter looking your own spice? Just curiosity.
Well, they have a global variation spice model, and then they have an app note on matching on local variation.
Okay.
And at this point, there is, as well. So, hacking the model to add that is.
So if you bring on it,
we want to know we can do, and then we'd have to verify that.
Okay.
Simulations, etc. Okay. So, some models out of XFAB, but I think the latest was they weren't going to provide base models to us. True, David? Or that was through Bernie's path.
Yeah.
Yeah. So, I feel some inquiries being made on getting something directly from XFAB, but we need to solve that first.
Yeah.
I can't give you the time frame at this point, but hope it's weeks and not months.
Exactly. Okay. We'll be checking in with each other. Have any questions, feel free to contact and Fearless and John Baptiste, who John is also, he just got online. He's in France as well, so he's probably your backup with the project. So anything that we can do also, data. And anything that we do in advance of doing the evaluation or whatever, just let us know. So my objective always is to hit the road running as soon as possible. When you give us the green light, we should be able. Yeah, I like to see it be a turnkey deal where you pretty much that same day you're dirty. So anything that we need to do, I'm sure that we have appropriate agreements in place already, given it that you find software from us. Just let me know, and I'll be on top of it. Just to make sure you guys start on time. If there's a training that needs to be involved, we will know that in advance, so we could have somebody come on site to do that training. Those are just some little administrative things that I like to just throw out there to make sure that once the green light is on, that we have a very efficient start, efficient transition of power, as they say today. Your hands on that variation manager.
Yeah, you can, forward me any questions, other things, regarding this. Basically, if you look in screen, this is your design, kind of,
Did we have a copy of their manual?
Okay. I can forward you those things, but so this is that band gap that, so I just kind of ran there, but a few issues, but it's good to go, kind of, a few things as I mentioned to David too, but meantime you guys can decide whenever you're ready, and go there.
Well, thanks so much.
Yeah,
right.
So taking time,
Very much.
Yeah, I'll send this user manual, and you can learn exam tutorial. I think there are, so I can forward you that later.
Okay. Everybody have
thank
a
you
good.
to the colleagues in France. I know we're late back there.
Yeah, that's what you want to be a little bit. That's what I say. Okay, they're not going to join that. Finally, thanks. They joined.
Well, I had a very early meeting that normally has someone India on it, but I think it got too late for him too.
Yeah, no, India is again. I was like other company. India is again. They either go home or I say, okay, I have to. Somebody has to wake.
Yeah.
Okay.
All right.
Well, have a great day, guys. We'll be talking to you soon.
Thank you.
Okay.
Bob and
Bye-bye.
David.